So today I've got 20 minutes or so to do a quick run through with you of the recommended list to give you a bit more information about how the recommendation decisions are made so that when you're out in the field using the list, you've just got a bit more of that background information. So a good place to start is, what are you looking for from a variety? And there's quite a few things that you could be looking for. A variety that's high yielding and high performing, a variety that has good agronomics and good disease resistance. It should meet end user requirements, have low inputs and be consistent both over years and between locations. Now, if I've asked you which of those features you look for more than the others, it will probably actually be all of those features is what you're looking for in a variety. The purpose of the recommended list is to do extensive trials and tests to enable us to make the recommended lists. And it also has a role in preparing and assisting the industry to make informed recommendation decisions. The current recommended list project is running until 2021, and at the moment we're in a time of change where we could see issues around the future availability of chemical control products, which we'll hear about later. And also, especially today, as we're getting more of these extreme weather events, the RL really does have a role to play in helping the industry to prepare. So the recommended list is managed by a consortium. And then the best of those will go into second year of national list trialling. At this point, the 2 years of national list data will be reviewed and the best varieties put through as candidates into the recommended list trialling system. After this first year in the RL system, the data will be reviewed again and the best varieties put through as recommended varieties. So although we may only have 3 to 6 varieties going on to the list each year, the concept of these varieties, it could be one of 800. The recommended list has trials across the country. This map shows the location of the winter wheat trials. The trials tend to be clustered into areas where the crops are grown, and also we try to put trials in different climatic regions as well. The lists are dynamic, with new varieties being added each year, but also varieties coming off the list as well. So here we have a summary of the changes in the current recommended list. We had in total 29 new varieties being added to the list, but we also had 28 varieties coming off the list. So roughly the list remained around the same size. So moving on now to the criteria for how varieties are selected for the list. Each crop has these tables of criteria with different characteristics given a specific level of importance. This table shows the criteria for winter wheat. I don't expect you all to see it, but just to know that there are different levels of importance attributed to each characteristic, and for each of the groups that importance may change. So for example, the Miller assessment is very important for the quality varieties and not so for the feed varieties. And I should say actually that those levels of importance do get reviewed on an annual basis. So when varieties are being considered for recommendation, a key question is, does the variety have a positive balance of features which makes it sufficiently better than existing varieties, and as such could provide a more economic return to the market? And to assess this, the committees will set a yield target, and varieties will be assessed against this target. New varieties which yield more than 2% above the yield target and meet minimum standards would be recommended. Varieties which fall into the green segment, which are above the yield target but by less than 2%, the expectation would be that they would be recommended unless they are shown to have a weakness against predefined comparative varieties. For varieties that fall below the yield target, the expectation would be not to recommend unless the variety has significant strengths and no weaknesses. If a variety has more than is less than the yield target by more than 2%, the expectation would be not to recommend unless it has something really, really special. An example would be resistance to a specific pest or disease. The end market criteria is also important. So here we have the NAB and group criteria and the number of varieties we currently have on the list in each of those groups. And obviously with quality, the proof is in the pudding, so to speak. So the recommended list carries out baking tests to determine quality. And we know that bread quality is affected by both genetic factors and by environmental factors. So a question that comes up a lot with the recommended list is there a way to measure consistency of a variety? And we've been doing some work with our colleagues over at BIOS to look at ways of measuring consistency. And there are two types of measure that BIOS have been able to identify with us. And firstly, sensitivity. And this is the degree to which a variety responds to a good or poor environment. And also stability. And this is the degree to which a variety's performance varies across trials. So if we look at some recommended list data, here we've got a comparison of treated and untreated yields over years. These are the same varieties, so it's possible to make direct comparisons between years. So if we look at the green line, which is the untreated yields, we can see there's a lot of variation there year on year, as opposed to the blue line, which is the treated yield. And this shows how important fungicide treatment is in controlling the level of variation and therefore reducing risk. So our colleagues at BIOS have done some further work on this time looking at regional differences in yields of particular varieties. So we've got the regional yields, we've got north, east, east and west yields of varieties plotted on the map, on the graph, sorry, and two varieties have been highlighted there, a quality variety and a feed variety. If we look first of all at the quality variety, you can see that the yield in the northeast is lower than the yield in the other two regions, whereas for the feed variety, the yields are quite consistent between the three regions. And what BIOS are saying is that the quality variety is more sensitive and therefore less stable, whereas the feed variety is less sensitive and more stable. So this type of work is probably promoting more questions, things like, can we determine what factors are affecting varietal stability? And by growing the RL trials over a number of geographic and climatic regions, we're developing this data set that we can start to answer some of these questions. And it also, as we've got future concerns over chemical availability, as we saw with the graph with the treated and the untreated yields and the higher variability in the untreated yields, these types of question and these types of analysis are likely to become more important in future years. And that's a good point to look at the pathology areas of the recommended list. So the recommended list puts out independent information on varietal resistance and susceptibility to disease through disease ratings. Each year we have approximately 170 different trials which provide data which go into the disease ratings, and there are three different types of trial. We have untreated trials which are replicated and yielded, disease observation plots which are single rep and not taken to yield, and then we also have inoculated trials. The inoculated trials are really valuable because they create a really high disease pressure which pulls out the differences between the resistant and the susceptible varieties. We normally use between 3 and 5 years worth of data to calculate the ratings. There are some exceptions, I'll come on to that in a moment. And this is how the disease ratings are calculated. We look at varieties that have got consistently high levels of disease, take an average of that disease, and an average of the disease rating that those varieties had in the previous year, and that gives us a high disease fixed point. And then we do the exact same thing for varieties which have got low levels of disease, and that gives us a low disease fixed point. Yeah. And then we use the relationship between those 2 points to calculate ratings for individual varieties. Now you'll notice here that the disease data has gone through a natural log transformation, and that's done to make it statistically easier to deal with. But this log transformation does have an effect upon the ratings, and it's something that you need to know about when you're looking at the ratings. So if we have a look, first of all, in the field situation, we've got here photographs of the Septoria disease ratings, or varieties with each of the Septoria disease ratings. And you can't really see the disease, but the key thing in this picture is to look at the green leaf area. So if we start to look at the rating scale, you can see as you go up the rating scale, the amount of green leaf area increases. But then if we look at comparisons between each of the ratings, you can see between a rating of 4 and 5, there's a big increase in green leaf area. Between a rating of 5 and 6, there's a big increase in green leaf area, but that difference isn't quite as big as it was between a 4 and 5. And between a 6 and a 7, there's an increase in green leaf area, but that difference is actually quite small now. And that's the effect of the log transformation. There are bigger differences in terms of level of disease between varieties with lower ratings than there are between varieties with higher ratings. So if you were making comparisons between two varieties, one variety had a rating of 3, the other had a rating of 4, that potentially is a very big difference in disease. Whereas if one variety had an 8 and one had a 9, that difference is going to be small. And for each of the diseases, we have a minimum standard in place, which the varieties must achieve to be recommended. This graph shows disease progression of yellow rust with varieties grouped according to their yellow rust disease rating. And you can see the blue line, those varieties that have not met the minimum standard have got a much higher level of disease, and this really emphasises the importance of those minimum standards. And again, in this graph, we can see the effect of the log transformation, as you've got much bigger differences in terms of level of disease between varieties with lower ratings than you have between those with the higher ratings. But it's important to remember that all crops need monitoring for disease, even if they do have a very high disease rating. We know that disease populations can change very rapidly, and they're able to overcome specific varietal resistances. And we saw this only last year with the yellow rust. I'm sure you all remember the massive yellow rust epidemic we had last year, and we saw some very unusual things in the field. And when we came to recalculate the yellow rust disease ratings, because there have been so many changes, we actually made the decision to calculate the 2016 ratings on just 1 year's worth of data to ensure that the ratings best reflected what was happening in the field. So we saw big changes, and here we have a graph which compares the ratings calculated in 2015 to the ratings calculated in 2016 and the proportion of varieties with each of the changes in rating number. In a normal year, it's very unusual to see a variety drop by 2 rating points. So having varieties dropping by 4 rating points really was unusual, and it showed the massive effect of that change in the yellow rust population. And then if we look at the effect on yield, we have a variety here that was affected by the yellow rust ratio changes. We have its treated and untreated yields from 2015 and 2016. The good news was that the 2015 and 2016 treated yields in blue were very similar, and it showed how effective fungicide treatment could control the disease. But if you look at the green bars, it had a massive impact on the untreated yield, and it just shows the risk there if the fungicide program isn't quite right. So it's really important to monitor all crops for disease, even if they have a very high disease rating. So moving on now to how the information is made available to you from the recommended list. During harvest, we've been putting out harvest results on the website, and in the next couple of weeks, we will be uploading that data into our interactive harvest results tool, where you can log on and interrogate the data for yourself. We will be publishing the new RL electronically in December, and the paper publications will be out in February. We will also update our variety selection tool, which is the online tool, in the spring of next year, and pocketbooks will be available as well. To make you aware that we also have weather data, which is available on the website through the monitoring link. and the RL team will be out and about in the field in the spring, summertime at demonstration events. So going back to where we started, I hope you've now got a bit more information about how the RL is put together and that you consider it as a valuable and useful independent tool for helping you make varietal selection decisions. Thank you.